So as a refresher, the three special products are one, a plus b squared is equal to a squared plus 2ab plus b squared. A minus b squared is a squared minus 2ab plus b squared. 3, a squared minus b squared, which is a plus b times a minus b. Now, how do we determine which one to use? If the middle term has a positive sign, typically in a trinomial or a polynomial of degree 2, that would be the number right next to x. If that number is positive, we're going to use the first special product. If that number is negative, we will use the second special product. The third one is the most important one because it's not even a trinomial. What we would have is a binomial. As long as we recognize it is of the form a squared minus b squared, we can split it up and write it as factors. So note a squared minus b squared is a binomial. It has only 2 terms. So we have x squared plus 6x plus 9, which we intend to factor using special products. So I look at that middle coefficient, which is the coefficient that is right next to x when it comes to a second degree polynomial, which we all know is a trinomial in most cases. So since that is a plus, we have to use a squared plus 2ab plus b squared. So that would mean a squared is x squared and b squared is 9. So sometimes I like to pick the middle term to associate and solve for a and b. Other times I'd go for the last term, but it's mostly a matter of choice. You pick whichever one you feel comfortable with. I'll show you both cases. So if a squared is x squared, and know a would be equal to x. If b squared is 9, b would equal to 3. And we know from the special product 1, a squared plus 2ab plus b squared is a plus b whole squared. Now I just have to plug the a and b back. X plus 3 squared. So x squared plus 6x plus 9 is simply x plus 3 squared, whole squared, which would mean x plus 3 times x plus 3. X squared plus 10x plus 25. So I look at the coefficient, it is positive 10. That tells me I have to use a squared plus 2ab plus b squared. So a squared is x squared. Here, I'm going to compare the middle term instead of the last term. So 2ab is equal to 10x. If a squared is x squared, a is x. I'm going to take that a equals x and plug it into ab. So 2 times x times b would equal to 10x. Divide by x on both sides. 2b would be equal to 10, which would mean b is 5. So I have the value of a and I have the value of b. So I can factor. We know a squared plus 2ab plus b squared is a plus b whole squared. A is x, b is 5. So x squared plus 10x plus 25 can be written as x plus 5 whole squared, which simply is x plus 5 times x plus 5. So I see a plus there. So we have to use a squared plus 2ab plus b squared. Since a squared is equal to x squared, we will have a equals x. B squared is equal to 36, which would imply b is 6. We know a squared plus 2ab plus b squared is simply a plus b times a plus b, which is a plus b squared. So a is x, b is 6. Do the same. You will have a plus 6 squared, which is x plus 6 squared. So we have x squared minus 8x plus 16. We have a negative there. So we have to use a squared minus 2ab plus b squared. Because of that negative matches with that negative. This would mean a squared is x squared, b squared is 16, a would be equal to x, b would be equal to 4. We know a squared minus 2ab plus b squared is a minus b squared. A is x, b is 4 squared. So you would have x minus 4 whole squared. So since we have a positive there, we have to compare it to a squared plus 2ab plus b squared. A squared would equal to 9x squared. 9x squared is the same as 3x whole squared. So a squared equals 3x squared, which would mean a is 3x. B squared is 25, which would mean b is 5. And as always, we know a squared plus 2ab plus b squared is a plus b squared. A is 3x, b is 5. So our factored version is 3x plus 5 squared. So since we have a negative, we have to use a squared minus 2ab plus b squared. This would mean a squared equals 4x squared. I have to write that as a perfect square. So 4x squared is 2x whole squared. A squared is 2x whole squared. So a is 2x. B squared is 9, which would imply b is 3. So we've got a to be 2x and b to be 3, which would mean a minus b squared. So a is 2x, b is 3. So 2x minus 3 squared. So the first thing to notice here is that this is not a trinomial. It's got only 2 terms. But 4x squared is a perfect squared. 9 is 3 squared, which is also a perfect squared. So what we should use is a squared minus b squared. A squared is 4x squared, which is simply 2x whole squared, which would imply a is 2x. B squared is 9, which would imply b is 3. We know a squared minus b squared is a plus b times a minus b. So 2x plus 3 times 2x minus 3. So 64x squared, I'll put it as a squared, and that would be b squared. So a squared is equal to 64x squared, which is 8x whole squared. B squared is 16, which would mean b is 4. And a would be 8x. And we know a squared minus b squared is a plus b times a minus b. A is 8x, b is 4. So we can write it as 8x plus 4 multiplied by 8x minus 4. So from the get-go, you can say that you can see that 16 is a common factor between 64x squared and 16. So if I pull 16 out, I will have 4x squared minus 1. Now, a squared is 4x squared, and b squared is 1. A squared would equal to 4x squared. This would mean a squared is 2x whole squared. That would mean a equals 2x. b squared is 1, therefore b is 1. So let's not forget about the 16 and realize, okay, we have a plus b times a minus b, which would equal a squared plus b squared. Since I pulled out that 16, I'm going to put that right here. A, b, 2x plus 1 times 2x minus 1. So the other way to write it would be 16 times 2x plus 1 times 2x minus 1. If you ask any math person or people involved in mathematics, would they want it in the form 8x plus 4 times 8x minus 4, or would they want it as 16 times 2x plus 1 times 2x minus 1? We would definitely want to go for 16 times 2x plus 1 times 2x minus 1, because the more factors or the more factorable form that I have for an expression, the better it is in mathematics. So sure, 8x plus 4 times 8x minus 4 is factorable. 16 times 2x plus 1 times 2x minus 1 is just better in terms of factoring. So a common mistake that folks tend to do is to look at 5x squared plus 36 and jump immediately to the conclusion of writing it as a plus b times a plus b. But it is not a plus b times a plus b, because if it is a plus b times a plus b, it would equal to a squared plus 2ab plus b squared, our first special product. Right there. So the given problem does not match any of the special products. And this is prime. Now, earlier I didn't get into detail as to what prime is. And I kept saying, as long as you cannot factor a trinomial in terms of real numbers, the trinomial is prime. What does it actually mean? This is a good way, or this problem is a good one to explain what prime means. So if 5x squared plus 36 is what we have, there is no way for me to split and write it as or in terms of factors. 5x squared plus 0x plus 36. Now, all I did is multiply 0 by x, and that would be 0. So all I did is rewrote 5x squared plus 36 as 5x squared plus 0 plus 36. Then I replaced the 0 by 0 times x. That's one and the same. 36 times 5 is what we need to have. What other ways could I write it? 18 times 10 is another possibility. 9 times 40 is another possibility. 12 times 30 is another possibility. Oh, excuse me, it's not 12 times 30. No, never mind. It is. So you look at these possibilities, you add 18 and 10, you get 28. You subtract, you get 8 or negative 8. That won't work. Add 9 and 40, you get 49. You subtract, it's going to give you 31 or negative 31. That's not work. That's not going to work because we want 0. Same, 12 and 30, not going to work. 30 plus 12, 42. 30 minus 12, 18, or negative 18, wouldn't work. So none of the factors would result in getting a 0, which would make this prime, like we have seen in the previous problem.